Hello everyone, welcome to BYJU'S exam prep. Welcome to your very informative class for your upcoming GATE examination. I hope everybody is doing very well and आप लोगों की preparation भी काफ़ी अच्छी चल रही होगी. So जल्दी से बताओ किस किसने session join कर लिया. Now this session is going to be an informative session. Also in the end of a session, I will give you one very good news about my upcoming schedule on YouTube. ओके सो सबसे पहले जिस सेशन ज्वाइन कर लिया है कमेंट सेक्शन में बताओ. ऑल्सो अपने दोस्तों के साथ और अपने स्टडी ग्रुप में सेशन को शेयर करो बिकॉज आज हम जो डिस्कस करने वाले हैं दैट इज अबाउट द एनालॉग इलेक्ट्रॉनिक्स. एंड जैसा कि आप लोगों को पता ही है कि एनालॉग इलेक्ट्रॉनिक्स काफ़ी बच्चों को थोड़ा सा मुश्किल दिखाई देता है. इलेक्ट्रिकल बच्चों के लिए इसका इंपॉर्टेंस अलग है, ईसी के लिए इसका इंपॉर्टेंस अलग है, लेकिन मोर और लेस इसका सिलेबस जो है आपका सेम रहता है. गुड इवनिंग कुमार. आज हम डिस्कस करेंगे कि क्योंकि आपके रिवीजन आप लोग कर रहे होंगे, आई एम प्रीटी मच श्योर अगर नहीं भी कर रहे होंगे तो एनालॉग आप कहीं ना कहीं स्टार्ट करोगे तो आप लोगों को पता होना चाहिए कि आप कितना उसमें देखना है, कितना उसमें रीड करना है, कितना उसमें आपको समझना है. ऐसा नहीं कि आप पूरा सिलेबस लेके बैठ जाओ और कोई भी एक बुक खोल के बैठ जाओ लाइक बोलिस्टर्ड और एनीथिंग एल्स. तो बुक खोल के बैठ जाओ, उसमें से आप देखते रहो 1000 पेज की बुक. ऐसा नहीं है. You have to study the analog electronics in a very concise way and study as much as you can score. ओके सो वो आज हम डिस्कस करने वाले हैं. कुछ इंपॉर्टेंट टॉपिक्स में बताऊंगा, इलेक्ट्रिकल के लिए अलग, ईसी के लिए अलग, एंड इन द एंड एनालॉग की एक सीरीज में स्टार्ट करने जा रहा हूँ यूट्यूब पे जो प्रैक्टिस सेशन की होने वाली है, तो उसके बारे में भी हम डिस्कस करेंगे. ओके सो जल्दी से बताओ किस किसने सेशन ज्वाइन कर लिया है एंड देन वी विल स्टार्ट. So let me introduce myself. My name is Shan Mudgal. I have a 7+ year of teaching experience. I'm Tech Gold Medalist from NIT Allahabad, 7 times GATE qualified, and these are my area of expertise. So first of all, before starting a session, tell me how's your preparation going on. Tell me how many subjects you have completed and have you started the revision or not, because we are in the month of May, in the month of November, and this month the revision must be very good. Okay, that you are doing the test series, you are applying various questions from a previous year. That is very important for this month criteria. Okay, let's start. So before starting the session, let me give you one information that your favorite Joshit sir is going to bring a session on the roadmap to secure under 100 rank in 2025. This workshop is going to be a very important for you all, for those students who are going to attend the GATE exam in 2025. For this, you have to register on our app, and also that this is live on 8 November at 7:30 p.m. It's open for all of you guys, so don't forget it. Also, we have launched our scholarship test. So I hope you have given our scholarship test that was on yesterday. So if not, so we are going to bring our scholarship test again. So don't forget to attend that also. All completed. Could you tell about the revision? Yes, Kumar. We are discussing about syllabus also and revision also. Mondal, I'm in 2nd year. Good bacha. If you start practicing from this year, you are definitely going to complete the syllabus on time with a proper revision. Also focus on your college studies along with it. Okay, so let's talk about the weightage. A simple concept we are talking about, that if you talk about for EC, the weightage is around 10 to 12 marks. 10 to 12 marks. Okay, why? Because it is a core subject for you. It is a core subject for you in a EC department. Whereas if you talk about the electrical, the weightage is around 4 to 6 marks. So if you see clearly that there is a half weightage for the electrical and for the EC student. For the electrical, it's not a core exam, and it's very much easier for electrical to score good marks. So I can say around the 80-90% marks in electrical from the analog. Why? Because the question that will come in your examination will be a straightforward, and the topics that you need to prepare is somewhere less as compared to EC, although the syllabus is pretty much same in both the departments. For EC, from the 10 to 12 marks, around 6 to 7 marks, the question will come out from an easier zone that you can do it very easily if you have a good basics of EDC, if you have a good basic of network. Then there's some question that comes from a moderate level. From a moderate level, you should understand the concept of analog very well to attempt those questions. Now, before starting the analog, there are prerequisite knowledge that you should have. There is a prerequisite knowledge that you should have. You should have a knowledge of KVL and KCL. You should have a knowledge of KVL and KCL. You should have a knowledge of transient. You should have a knowledge of transient analysis. Now, if you see carefully, both of these topics you read in case of in subject of network theory. So before starting the analog electronics, even before starting the revision of analog electronics, revise the network theory very well. This subject is a base for many other subjects, including analog. So these two topics like KVL, KCL, transient is very, very important if you want to score good marks in analog. Okay. If you have completed this topic now, around 60% of your analog syllabus is already complete. Around 60% of your analog syllabus is already complete. Okay, so let's see the chapter wise distribution that you should do for your analog electronics. Okay, so the first chapter we have is a diode circuit, or you can say the diode. Chapter 1 is your diode. Now, this chapter is an important chapter, but one thing is good. This is the smallest chapter you have. It is the smallest chapter you have. And if you talk about electrical and EC, so on an average, I'm talking about on an average, from electrical, you can get 1 or 2 questions from here. From EC, you can get 2 to 3 questions from here. You can get 2 to 3 questions from here. So on an average, also, this is the smallest chapter we have. So you are going to take at least if you want to prepare very well, you're going to take at least 8 to 9 hours to complete this chapter for a revision. It should not take more than 3 or 4 hours to revise this particular chapter thoroughly. Now here you can see the topics we have is a diode circuit, one of the important topic we have. Of course, for this particular chapter, you should know the working of diode, or at least you should know what is the cut-in voltage, what is the breakdown voltage, what is the junction, what is the Zener breakdown, what is the meaning of avalanche breakdown. These small topics we have here, and you should understand what is the diode circuit. For example, if you talk about in a DC analysis, we can represent a diode like a voltage source in series with resistor. I'm talking about the complete model. So this is gamma. Sorry. This is the cut-in voltage V gamma. This is RD. Okay. This you can say the forward resistance, or you can say the forward resistance. This you can get in case of forward bias. In case of reverse bias, this will be open circuit. Now what happens in case of AC analysis? In AC analysis, generally, in case of forward bias, we represent as a resistor, which is a dynamic resistance, or sometimes we actually represent it with a parallel with capacitor, which is nothing but a junction capacitance. Okay, so in this way, and in open circuit, in reverse bias, it will be open circuit. So the knowledge of these particular topics, which are very, very small topic, you should have. Once you have a knowledge of this topic, you can easily complete this particular concept of diode circuit. In diode circuit, we learn the open circuit and short circuit test. And guys, this is one of the powerful method we have in the diode circuits, because once you know what is the open circuit and short circuit test and how to apply it, then you can solve any question from a clipper, clamper, from a rectifier, from a voltage regulator. The base of open circuit and short circuit test will tell you which diode is on and what is the condition at which that particular diode will be on. Based on condition, you can draw your circuit or draw the model based on diode. That's why guys, open circuit and short circuit test आपको अच्छे से करना है. Don't need to leave this particular topic. It's very, very important, because the whole chapter is based on that. And if you want to score a good marks in both electrical and EC, this is going to be important. Okay, understood? After that, we have a clip and clamper, and from a clip and clamper, a very good question can be formed, especially for the electrical examination. If you see the previous year question, you will find out that more question has been asked in electrical as compared to EC. So clipper and clamper is basically important for the electrical, but also the topic is simple. If you know the short circuit and open circuit test strategy, then this is very easier topic to attend. After that, a rectifier and filter. So rectifier, this is the topic that electrical student already learn in case of power electronics. So for electrical students, no need to go through the rectifier in this particular subject, because you already learned this topic in case of a power electronics. Fine. Whereas in case of EC, for EC it is an important topic. But for EC it is very much simpler. You need to find out what is the meaning of average voltage, RMS voltage, how to calculate it using a waveform and all. So it's going to be an easier topic for EC student also. So don't worry about this. Rectifier is simple. Also the basic that you should have use here is the open circuit and short circuit test. Okay. Then a voltage regulator. Voltage regulator is an important topic for both branches. In a voltage regulator, we basically deal with a Zener diode. Okay, now Zener diode, it's one of the important topic and also a very interesting topic if you go through it. In a Zener diode, you know how to deal with a voltage regulator. Also, instead of voltage regulator, you can also get a questions. You can also get a question from a different normal diode circuit in which the Zener diode is connected. So for that, you should understand the different models of Zener diode and conditions to pass it. So all of these are the numerical based topics from where if you cover the second topic well, you can have a good chances of getting perfect marks or 100% marks in case of a diode chapter. Okay, any doubt till here? And guys, I can see the people watching are less, so share the session among your friends, because jitna zyada aap share karoge, it will help you and other students also. They can get a good information from here. Sir, I haven't started analog yet. Can score marks in the subject if I follow your YouTube classes? Yeah, but yes, beta, you can follow the YouTube classes. You can follow the practice sessions that I have bring the last month also, this month also, and also on app. So practice a lot of question and practice in a systematic way. For example, starting from chapter 1, then go to chapter 2. In chapter 1, if you are doing now, let me tell you, try to complete at least 100 to 120 questions. Try to complete at least 100 to 120 questions from this chapter. And where you can get questions, you have a previous year papers, you know, electrical ECIN, you have a previous year paper of all of these three branches. Then test series you have, study material you have to practice the questions from these particular sources. Then if you have any doubt in any topic, you can practice from books also, but prefer the book in the end. First prefer the test series and the previous year question. Next chapter we have up chapter BJT. Now in BJT, biasing topic is very important for electrical students. There is a 90% chance that the question from biasing will come from the electrical student. So this particular topic is very, very important for electrical. But for EC also, if you don't know how to do the biasing, you cannot go to a BJT amplifier. Okay, so for electrical students, this topic is important for the numerical perspective. For EC, this topic is numerical if you go to a BJT amplifier. Now from a biasing of BJT, you learn a different type of biasing, like self-bias circuit, ammeter resistor circuit, ammeter resistor biasing, fixed bias circuit, ammeter resistor bias circuit. Also the fixed bias circuit, we learn the fixed bias circuit and much more. So bacho, this point is very much important, how much you are studying. For electrical, this topic is very important. You can get definitely a question from a biasing of a circuit. Now when you go to a BJT amplifier, if you go to a BJT amplifier, then there are three models actually. In BJT amplifier, we actually do the AC analysis. And based on AC analysis, we have three models. One is RE, one is R pi, and one is H model. All of these three models are important. But I will, if you want to prefer one topic, then prefer the RE and R pi. You will see that all these models are interlinked to each other. So if you prepare one model thoroughly, then you can easily interlink the other models like R pi and H model. Okay, so RE and R pi models are more important as compared to H model. Prepare one model and try to interlink other models also. Okay, this particular topic of BJT amplifier is more important for EC students, so you should know how to draw the models. For electrical student, you can just remember a one or two formulas based on this model, like voltage gain formula and input resistance formula, and that will be enough for you. But for the ECE, you should understand how to draw the models. Once you draw the model, you should understand how to do the analysis. We use the KCL KVL method for the analysis purpose. we use different Thevenin resistance method. So all of this method you should understand, then only you can go ahead and solve the question based on it. And you can easily and definitely assume one question will come from the BJT amplifier. Okay, any doubt till here? Any doubt? Next we have two topics, which is a multi-stage and differential amplifier. So multi-stage amplifier basically contain topics like cascade amplifier, like cascade amplifier, है ना, Darlington pair. So these are the topics comes in a multi-stage amplifier. For electrical, this is not an important topic. For electrical, this is not important topic for gate examination. But for ECE, the question can definitely come. So don't forget to go through these topics like cascade, and Darlington pair. This topic become easier if you know how to draw the model of BJT amplifier. Because in these topics, you need to draw the model only and then apply the KCL, KVL. Basically, we have to use the two BJTs here. So that's why. So this topic is easier for those who have prepared the second topic, which is the BJT amplifier. Again, I'm repeating, for ECE, it is important, the multi-stage amplifier. For electrical, it is not important. Okay. Now, differential amplifier, it is direct formula based. It is direct formula based. And if you see, there are few formulas here. It's direct formula based. And we have a few formulas here like voltage gain, input assistance, output assistance. So you can remember the formula. Again, from the electrical, the chances are less, the question will come. But from ECE, the chances are more. So this is your chapter 2. Next is a chapter 3. Now, before going further, let me give you one information. We have discussed all of this thing in a chapter 1. So let me tell you, starting from tomorrow, I'm going to bring classes on this particular topic like open circuit test, clipper and clamper, rectifier and voltage regulator. So for the complete week, I'm going to discuss the question over this topic. So you have to attend the classes correct at 3 p.m. Starting from 3 p.m. on YouTube. So don't forget, we are going to discuss a lot of questions based on these topics. So chapter 1 is going to be start from tomorrow for you on YouTube. Next, we have a MOSFET. Just like BJT, in MOSFET also we have a biasing. And again, for the electrical student, it is more important. For electrical student, it is more important. You can expect direct question from a biasing. From ECE, you can direct question, the chances are very less, but it create a base for your amplifier biased circuit. So for an amplifier circuit, this is going to be important for ECE. But one thing is very good. If you have done the BJT amplifier, then FET amplifier is very simple. There is only one model, R-Pi model. There is only one model here, which is a hybrid pi model. Unlike in case of BJT, we have three models, RE, R-Pi and H. Here only we have hybrid pi model. And the particular model is also simple. Because as you know, in MOSFET, the input resistance is very high, approach to infinite. So particular model is also simple here. Then we have a current mirror circuit and the multi-stage amplifier, just like the BJT. But in current mirror circuit, this is an important topic you have. For both electrical and EC. But again, topic is simple. You just have 2 or 3 formulas to remember here to find out output current based on input current. So topic is very simple. Analysis part is not that much important here. You need to remember finally the formulas. So this is going to be important. But let me tell you one thing better. If you think that only remembering the formula can give you good marks in analog, that is not going to be true. Because you can find out many formulas in amplifier and most of them are useless. They are not going to use anywhere in your particular question. But if you do the analysis carefully using the KVL, KCL, if you know how to draw the model, for example, in amplifier based on FET, you have to draw the model of hybrid pi. So once you know how to draw the model, then applying the KCL, KVL in there is very much easier. So whenever you are doing the revision or you are doing the preparation, go through the analysis part once. Because in exam, they can trick you. They can give you a random circuit. And ask you what is the gain, input and output assistance here. So if they give you like this, so you should understand. If you have strong in analysis, you can attempt that question very well. Otherwise होगा क्या, आप तो छोड़ के आ जाओगे, and then after some time you will realize कि यार वो question तो easy था. Why did I leave that particular question? That is very much easier to do. Okay, so that's why I told you KVL and KCL are very important. KVL and KCL are very important. Okay. Next chapter we have an operational amplifier, and the complete chapter is very important for both electrical and EC. The complete chapter is very important for both electrical and EC. In electrical, you are going to get maximum questions from this chapter as compared to other chapters in analog. So in this, we are going to get a maximum question. Okay. So what is the operational amplifier? In this, you need to understand the working. If you talk about the electrical student, you can remember the formula directly, the voltage gain or in the negative feedback and positive feedback. But I will advise one thing. If you're remembering the formula directly, you should remember the conditions also. For ideal op-amp, there is a different formula that generally we use and generally we remember. In case of practical op-amp, we have a different formula. So this particular demarcation, you have to know ki what formula you have to use in which question. So that's why sometimes the question can trick you. They will give you a practical op-amp, but you are using the ideal op-amp formula. So this you need to understand very carefully how to make a differentiation. Apart from this, in op-amp working, you should understand what is the virtual ground, because every question in negative feedback based on the virtual ground concept. So you should know what is the meaning of virtual ground, a very important thing. Okay, now there are small topics there also, like the slew rate, like the offset voltage, offset current. So these small topics are important. 1 mark question can frame from these topics, or since the MSQ question has been asked in the GATE exam, so they can include 1 or 2 statements based on this small topic, ki what is slew rate, what is the offset current, what is the meaning of that, practical significance of that. So these you should understand carefully. Then we have a linear application. Now linear application, definitely 100% you are going to get 1 question from a linear application. In a linear application, you have many circuits like summer, okay, like differentiator, integrator, differentiator and integrator. We have a circuit like half wave rectifier, full wave rectifier. So we have a different topics that we got in a linear application. So go through these topics very well, and there's no need to go through each and topic in a very particular way. If you know the concept of negative feedback thoroughly, you can find out the formulas there easily. No need to remember the formula in every case. Just you need to understand, if I know the virtual ground concept, if I know the negative feedback, then I can do the analysis very easily in a less amount of time. Okay, so don't go and remember each and every formula. It will create a huge mess for you, because there are more than 30-40 formulas we have in op-amp. So don't go and remember all of them. Then non-linear application is also important. Active filters, inactive filters in electrical. For electrical, 2 topics has been added. One is Salon key filter. And another one is Butterworth filter. So these 2 topics has been added in electrical, but if you see the previous year question, no question has been asked over these 2 particular filters. So you can, if you want, you can skip it. Otherwise the topic is simple. But go through the active filters also. For example, like high pass filter, low pass filter, how to identify it, what are the characteristics. So go through these topics very well. Once you go through it, you can cover the 80-90% of active filter thoroughly. Then you have a Schmitt trigger and multi-vibrators. So from these topics, multi-vibrators are more important for ECE as compared to electrical, and Schmitt trigger is more important for electrical. So in Schmitt trigger and multi-vibrators, we actually use the concept of positive feedback, and from the positive feedback the question is come, they will definitely come from Schmitt trigger, and it can come from multi-vibrator also. But to complete this topic of Schmitt trigger or multi-vibrator, you should know the concept of transient analysis. Ki how you will charge the capacitor, how the capacitor will discharge, what are the waveforms they can make. Hello Ashish. how you can make the waveform when the capacitor is going to charge and discharge. So transient topic, you should have a good command. When you have a good command of transient topic from a network theory, you can easily do the question on Schmitt and multivibrator. And you will find out this is also easier. Why? Because the output voltage waveform remain same in both the cases like a square waveform. So that's why this is a very, very important topic for both electrical and EC. So don't miss it, because topic is simple. Just by seeing the waveform, you should not miss this topic. And also transient analysis. From a network theory, the transient analysis is going to use directly here. So you should go through a transient analysis carefully. Even standalone, this topic is important. You can get 2 questions from this topic in your GATE exam. Okay. Next, we have the last chapter. We have a last chapter which is a feedback amplifier and an oscillator. So if you see the feedback amplifier and oscillator, you have a topics like type of feedback amplifier, like we have a current control current source, voltage control current source, or we have amplifier like transconductance amplifier, voltage amplifier, current amplifier. So all of these topics are important. But Ashish, watch this video from the starting. I told you for a particular subject, for a particular chapter and topic, which topics is important for EC and electrical. So you can watch this class from starting. Even though if you have any doubt, you can leave the comment in the comment section. Also, you can join my Telegram channel and ask your doubts there. Okay, so type of feedback amplifier. These topics, type of feedback amplifier, parameter of feedback amplifier, both of these topics are important for electrical and EC, but it is more important for EC students. Okay, if you see the previous year question, you can find easily that even after 2 or 3 years, this topic is repeating. Okay, so important. Then these topics are simple. LC oscillator and Wien bridge oscillator. You need to remember the formula of frequency here, which is very much easier to remember. You need to remember the Barkhausen criteria here. You need to remember the Barkhausen criteria here. The spelling is wrong, but the criteria is simple. You need to remember Barkhausen criteria here, which is A beta is equal to 1. So these topics are simple. Again, for EC, this topic is important. For EC, this topic is important. For electrical, remember the formula directly. What is the frequency formula of LC oscillator and Wien bridge oscillator? That is more than enough. For EC, go through the analysis once. It may happen that they can ask you other things in between the analysis. But again, the more chances that they can ask you the frequency directly. Now next is a 555 timer. Although it's not the part of a GATE syllabus, 555 timer. But once or twice the question has been asked in electrical. Okay, so just I have added a 555 timer here, but if you don't have a time, you can skip this topic. This topic is based on multivibrator or the monostable and bistable that you have already seen in case of a positive feedback. So you can skip this topic. There is not necessary to complete this topic, but remaining topic you can do, because easily one question will come out of these 4 topics. Let me tell you, out of this topic, one question will come. And more important, it can be of 1 mark or 2 mark. More chances the question will come for 1 mark from this topic. Okay, understood? So all of these we have discussed about chapter 4, chapter 3, chapter 2, chapter 1. Okay, let me tell you one more thing. Guys. From tomorrow, or you can say today is actually 6th November. So from 7th November, 3 p.m. on YouTube, I'm going to start the classes on diode. But remember, we are going to discuss questions here because the revision time has started. So tomorrow we are going to discuss question over the open and short circuit test. Tomorrow we will discuss the question over open and short circuit test. Then day after tomorrow, clipper and clamper. Then voltage regulator, rectifier. So all of these topics questions we will complete at least 15 to 20 questions, so that this topic will complete accurately. Because from here you can expect easily 1 or 2 questions there. So approximately 2 or 3 marks question can come from here. So don't skip this topic. It's very important. Okay. So before ending a topic, let me give you one particular information. If you haven't downloaded our app, then download our app from a Google Play Store by the name BYJU'S Exam Prep. In this app, we are providing you many features. Apart from a free classes that's going on, we have a feature like the leaderboard where you can participate in quiz, you can see your score like this, and you can compete with your fellow aspirants, and you can understand the examination environment while solving the quizzes. So this is very important. Also, my free classes are going on there, and I'm going to start the free classes next week, and I have taken the free classes last month also, so you can watch all of these videos also. So before ending a session, let me tell you that we have already launched the GATE 2024 crash course. So in this course, we are providing you the live classes, recorded lecture, study material, mock test, and practice quizzes. So if you haven't enrolled in this course, I will advise you to enroll in it. We are practicing a lot of question here with a lot of theory. So I hope you understand this session, guys. So from tomorrow, don't forget to join the session at 3 p.m. Till then, bye-bye, take care, and study well.